What's up, guys? In this video, we're going to work on how to solve a system of equations by graphing. And what we're going to do is going to work on 3 easy problems, 3 medium, and 3 hard. So therefore, by the end of this video, you'll have a great understanding of not only how to graph a system of equations, but how to find the solution. I hope you enjoy. What's up, guys? In this video, what I want to do is tackle 3 really important problems that you absolutely need to know if you're looking to pass your test, your quiz, or your class, because these are the types of problems that are going to show up and really set yourself apart, that you understand how to solve a system of equations by graphing. So let's go and take a look at these 3 examples so you are off and ready and prepared to handle your next assessment. So in this first example, you can see I have y equals -1. Typically, when we're graphing lines, we like everything to be in y equals mx plus b. So there's no m, there's no x, and there's no b. What are we going to do here? Well, in reality, this one actually can be written in slope-intercept form. You can actually rewrite this as a 0x minus 1. So therefore, our slope is going to be 0, and our y-intercept is actually going to be a -1. So in this case, we can say b is equal to a -1. So what I'm going to do is I'm going to go down to -1, and I'm going to graph my y-intercept. Now, the next thing I want you to recognize is when I have y is equal to -1, since my slope is 0, that means there's going to be no change in rise over run. Meaning what that's going to do is that's going to create what we call a horizontal line. So therefore, y equals -1 is just a horizontal line with a y-intercept at -1. Now, in this next example, I have 3x plus y is equal to 5. And some students might say, well, when you have x and y, you could use the intercept method to graph the line. And yes, to graph a line, you can use the intercept method. However, when we're solving a system of equations, I cannot recommend this highly enough. Please put it in slope-intercept form so you can go ahead and follow the slope to find your intersection point. Because again, that's what we're looking for when we're solving a system of equations, is what is the point where the 2 graphs are going to intersect. So to go ahead and rewrite the slope-intercept form, what I'm simply going to do is I'm going to subtract a 3x on both sides. So by subtracting a 3x on both sides, I have now isolated my y. So y is now equal to a -3x plus 5. Now it is in our form of y equals a mx plus b. Now again, it's very important to recognize here that this -3 represents our slope, which means I can rewrite this as a fraction. So therefore, I can say that m is going to equal a -3 over 1. Or you could also go ahead and rewrite this as a 3 over -1. Because again, anytime a negative divided by positive or a positive divided by negative, this understanding might be helpful in this problem or maybe in another one. Just make sure you don't make both the top and the bottom negative, because then that would create a positive slope, which obviously we do not have. We have a negative slope. And my y-intercept in this case is going to be 5, which again, you can rewrite that as a coordinate point of 0, 5. All right, so let's go over to my y-intercept at 5. So 1, 2, 3, 4, 5, because again, this is my y-axis, that's my x-axis. Again, my goal here, guys, is to go down, right? I want to go down over here. I want to find where is this going to intersect. So what I'm going to do is I'm just going to follow the slope. Now again, I don't want to use the +3, -1, because that's going to tell me to go up 3 to the left 1. I don't want to go up and to the left. I want to go down and to the right. So that's why I'm going to use this representation of the slope. So I'm going to go down 3, right? That's change in y is 3. So between any 2 points, you're going to go down 3 to the right 1. So down 3, 1, 2, 3 to the right 1. Okay. And now what the nice thing about using slope-intercept form is I can do that again. Go down 3, 1, 2, 3 to the right 1. And you can see here, now we have found our intersection point. So I can just kind of sketch a nice little graph here so you can kind of see that. And we can see these 2 graphs intersect at the common point of 2, 1. That is going to be the point that's going to satisfy both of these equations. Meaning if you plug in a 2 in for x and a 1 in for y into either of these equations, it's going to make the equation true. Hopefully you recognize that's not a positive one, that needs to be a -1, right? Because if you plug 1 in for y, obviously it's not going to be right. It has to be a -1. All right, now in the second example, you can see we have 2 equations in standard form. And a lot of students don't want to deal with these questions because it does take a little bit more work, right? Of course, we like things when they're already in slope-intercept form. But this one, yeah, we just need to solve for y. So whenever you have a problem like this, and it does require a little bit of work to put them in slope-intercept form, just go and do that on the side, right? Or do that on another sheet of paper, whatever you kind of need to do in that case. So what I'm going to do is I'm just going to say, all right, so if I need to solve for y, right, I want to put this where y is going to be isolated. Y equals mx plus b is the form I'm looking for. So the first thing I'm going to do is I'm going to subtract an x on both sides. Therefore, I have a 2y is equal to a -x plus 6. I'm going to divide by a 2 and make sure you divide that 2 into the x as well as into the 6. Now, y is going to equal, now you can't really divide a 2 into the x, but you can divide the 2 by the 1, which is a coefficient. So that's going to be a -1/2 x and then plus 3. So now my m, which represents my slope, is a -1/2. And my b, which represents my y-intercept, is going to be a 3. Now in this example, I kind of have the very similar idea. So I have a 2x plus y is equal to a 9. Here, the only thing I need to do though is subtract a 2x. So therefore I have y equals a -2x plus a 9. So again, I can rewrite this as a -2 over 1. Therefore my slope here is going to be a -2/1, and my b, in this case, my y-intercept is going to be 9. Now let's get into some graphing. So first one here, the y-intercept is at 3. So here's the y-axis, right? So we'll go to 3, 1, 2, 3. And now I'm going to follow my slope. Now, should I go up and to the left or down and to the right? It doesn't really matter at this point. Just remember that -1/2 is really the same thing as 1 over a -2. Sometimes if you look at the other problem, you might get a little bit of a tip, but if you don't really know, what I would recommend doing is just go ahead in both directions, right? So I could go down 1 to the left 2. So if I went down 1 to the right, down and to the right 2, or I could go up 1, changing the y is positive and the change x is -2. So I could go up 1 to the left 2. So I'm going to go in both directions because I don't really know which one's going to be more advantageous for me to finding the intersection point. And sometimes you do need to extend the lines as well. And now I need to go ahead and graph this one. So now I have a y-intercept of +9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And now I have a slope of down to -1. Well, obviously, if my slope is going to be, I don't want to go up, right, and to the left. I want to go down and to the right. So we're going to go down to the right and then down to. So sometimes it's also helpful to kind of do a little slope triangle, right? So that creates that line here. And then you can go down to the right, down to the right, and then down to the right. Okay. And now you can see that this line here has been created, which is going to be just right there. And again, you can see it follows along my nice little slope triangle here. And there's going to be our point, which is at 1, 2, 3, 4, and then comma 1. All right. So sometimes it is going to take a little bit of work to be able to, keep on following your slope. But that's why I think it's just so important to graph one line and then use the other line to kind of gauge where you need to go. And again, just follow the slope, find the y-intercept first and then follow the slope to find your intersection point, which again is going to be your solution to the system. All right. Now this example, again, we have two equations. Now this one's already solved for y. So that's good. So we have y equals a 1/2 x. Now in this case, we have our slope is going to be a 1/2, but we don't have a b, right? We don't have any constant. So in this case, our b is going to be a 0 because you can easily just go ahead and write +0 if you wanted to. So therefore, this is going to go right here. And then we're going to follow our slope up 1 over 2, up 1 over 2. And again, just remember that you could also rewrite this as a -1 over a -2, right? Because negative divided by negative is positive. Now, the reason why I'm doing both directions is I don't really know what this graph is going to look like. And so I just want to kind of be prepared of having to extend in kind of both directions. Now, again, you only really need 2 points to go through there to draw the equation of the line. But I just want to kind of make sure you're aware of that because it is very helpful to know. Now, let's go ahead and deal with a problem like this. We do need to know how to deal with fractions, or at least be familiar with them to help us go ahead and solve this equation. So I have a 1/4 x plus a 1/2 y is equal to a -2. All right. Again, remember our goal here is to put it in y equals mx plus b form, right? So the first thing I'm going to do is I'm going to want to isolate my x. So I'm going to subtract a 1/4 x to the other side. Therefore, that's going to give me a 1/2 y is equal to a -1/4 x minus 2. So what I'm doing is I have right now my y is being multiplied by 1/2. So what I could do is I could divide by 1/2. But remember, dividing by a fraction is the same thing as multiplying by the reciprocal. If I want to get rid of this 1/2, I could multiply by a 2/1. Now I'm going to do that on the right-hand side. Just make sure you put parentheses around it because you have to go ahead and distribute that. You have to multiply that 2 to both the -1/4 x and the -2. So now this is going to multiply to a 2/2, which is just 1. So that's going to leave me with a y equals now a 2/1 times a -1/4. Let's go and rewrite that over here. So I have a -1/4 times a 2/1. Now again, you could just multiply this through and reduce, or you could say, well, 2/4 reduces to a 1/2. So therefore, this is going to be a -1/2 x. And then this is going to be a -4. So now let's go ahead and find our y-intercept of -4. So 1, 2, 3, 4. Again, remember our slope is negative, right? So this is going to be a -1/2, or we could rewrite this. So I could say m is equal to a -1/2, or m is equal to a +1 over -2. Now this is really important because a lot of these problems up to this point, we always went to the right. Everything was going to the right. So in this case, I don't want to go to the right because again, what the right is saying, you're going to go down 1 to the right 2. So down 1 to the right 2 is going to go over this way. I'm never going to find the intersection that way. I want to go to the left, meaning I want to find where my x coordinate is going to be negative, which is going to be using this slope. So therefore, what I'm going to do is I'm going to say, all right, the change in y is a +1, and then I'm going to go to the left 2. And then I'm going to change the y as +1, and then go to the left 2. And now you can see I have found my intersection point, which is actually to the left of the y-intercept. And again, I forgot to mention b is equal to a -4. So let's go and find out where this intersection point is, which is at 1, 2, 3, 4, -2. So we have a -4, comma -2 is going to be the coordinate point that's going to satisfy this system of equations. Again, meaning if you plug this point into both these equations, it is going to make them true. Hopefully a review of these 3 problems, guys, is good enough to get you by on your next test or quiz. But if you really want to shoot for that A, if you really want to have a strong understanding of solving a system of equations by graphing, then check out the next video I have for you here. What's up, guys? In this video, what I want to do is tackle 3 difficult problems that you can expect to see when trying to solve a system of equations by graphing. Now remember, when we're trying to find the system of equations by graphing, what we're going to want to do is graph the 2 lines and then use the intersection point. And you can see in this first example, I have both my equations in standard form. Now we want to find the intersection point of our 2 equations. We want to make sure that our 2 equations are going to be in slope-intercept form. Remember, that's going to be in the form of y equals a mx plus b. The reason why these problems can trip up students is because we have to go ahead and solve each of these equations for y. So the first thing I'm going to do is I'm going to go ahead and put both these equations. I'm going to do work on the left-hand side, and I'm going to go ahead and solve for y. So let's go ahead and rewrite the first equation. All right, now let's go ahead and solve for y. So again, what we need to identify is what is being applied to y, right? You can see we are adding a 4x because that's a positive, and we're actually multiplying by -5. So therefore, I'm just going to go ahead and apply my inverse operation to go ahead and solve for y. Okay, and you see this problem wasn't too bad, right? Y equals a 4/5 x. Now again, we don't have a b, so you could always go ahead and write that in as a 0. So basically, my y-intercept is going to be at 0, and then the slope is, right, the change in the y over the change in x is going to be 4/5. So therefore, I'm going to go up 4, 1, 2, 3, 4, and then over 5, 1, 2, 3, 4, 5. Okay, now I'm going to do that in the same way, going down to the left, just because I don't know where this intersection point is. I always like to go ahead and find 2 points from my original y-intercept, one to the right, as well as one to the left. So to go ahead and find down to left, I'll just do a -4 over -5, because again, that's still a 4/5. So 1, 2, 3, 4. 1, 2, 3, 4, 5. And now I'll just go ahead and connect these 2 points. Now we need to go ahead and apply this process for the second equation. So I'll go ahead and rewrite it and then go ahead and solve for y. Okay, now you can see, again, I just used my inverse operations, right? I subtracted the 3x and I divided by -5. And that gives me an equation of y gives me a 3/5 x plus 1. Now in this case, we have a y-intercept, right? Which is going to be a 1. So I'm going to go ahead and plot a point here. And then now I can just go ahead and follow the slope. Now this one is not very obvious where this intersection point is going to be. So I'm just going to go and follow the slope exactly as it's written as a 3/5. So that's going to be up 3 over 5. So what we'll do is go up 3. So 1, 2, 3, and then over 5. 1, 2, 3, 4, 5. And you can see here, this is actually going to be our intersection point. So now what we need to do is go ahead and figure out, well, where exactly is this point, right? And by looking at the table, which hopefully I went ahead and graphed correctly, is going to be at the coordinate point of 1, 2, 3, 4, 5, 1, 2, 3, 4. So that's going to be at the intersection point of 5, 4. All right, now in this next example, you can see it's basically kind of the exact same thing going on, right? We have 2 linear equations that are set in standard form. So the best advice I can give to you when you have equations that are in standard form, don't try to solve them using the intercept method. While the intercept method is very helpful in graphing linear equations, it doesn't really help us find the intercept point unless you're being really, really exact with your graphing, which we know is not always going to be the case. So the best way to be able to find that exact intersection point with 2 lines that you're graphing is using slope-intercept form. So the first thing I'm going to do is I'm just going to go ahead and rewrite these 2 equations and again, solve for y using my inverse operations. Okay, there's a couple things that I wanted actually to mention about this, which I didn't talk about in the previous example. Notice when I divided a -6 on both sides, I divided the -6 into the 9 as well as to the 24. So it's really important to do that. A lot of students will sometimes only choose like one of those numbers, and that's incorrect. You got to make sure you divide, when you're dividing a whole expression by a number, you got to make sure you divide both of your terms by that value. The other thing I want you to see is I just kind of wrote this as like a 9/6 and then plus a -4. And then I just rewrote one extra line as the simplified version. Because typically when we're graphing, we always want to use a simplified version. A lot of times students can make mistakes when they're trying to do so much math in their head. So that's why I just went ahead and wrote this extra line, which I really didn't have to, but it just kind of a lot of times helps me make sure I'm keeping the counting of doing all the steps correctly. All right, so now let's go and do the second equation. Okay, now in this equation, I did do the math a little bit in my head. A lot of times we aren't taking a test or a quiz, we are kind of heading against time. It really just kind of comes down to your comfort level, and I just don't want you to be making mistakes. But there's something really, really important that I want you to understand here is we actually have the exact same equation. So if you didn't simplify this, you might not have recognized that these are the exact same equation. That's why it's so important to make sure you can simplify your 2 equations. Now, it's really important to remember whenever we have a system that's the exact same equation, what we have is what we call an inconsistent solution, meaning we have infinite many solutions. And the reason why I have infinite many solutions is because the graphs are going to intersect each other infinite many times because they're exactly on top of each other. So there's infinite many intersection points. Well, let's just go ahead and graph this so we have an idea of what this system looks like. But again, it is going to be the exact same line. So therefore will be infinite many solutions. So again, I just went ahead and found the y-intercept, which is -4. And then I went up 3 over 2 to go ahead and find my next point. And when I had to connect to those, I only needed to do it once, guys, because the same line exactly the same. But again, remember, whenever this does happen, that's going to give us a solution that is infinite many solutions. Now, in this example, we're actually going to follow the exact same process. But what makes this one difficult is the fractions. And I know a lot of times when students see fractions, they immediately freeze up because a lot of times they perceive the problem to be much more difficult. And sometimes that is the case, but a lot of times that is not. Regardless, what I want to do for this problem is make sure I'm going to go step by step to kind of explain exactly how to do this with the fraction. Because again, I totally understand as a student how fractions can trip you up for a problem like this. But again, I want to get you to an A. And sometimes the difference between A and a B is being able to understand problems when fractions are involved. So again, to be able to graph this, the first thing I want to do is go ahead and rewrite our equations in slope-intercept form. So therefore, we have to use our inverse operations. So the fractions are not going to make the inverse operations any more difficult. We just have to undo what's happening to the y. So we recognize the y is being added to the 1/2 x as well as being multiplied by a -3. So again, just like the previous problems we did, we just need to undo these inverse operations. However, this is where some fractions will start to get difficult. But the first thing we want to do is just go ahead and subtract a 1/2 x to both sides. And now we need to undo multiplying by -3. So therefore, we're going to divide by -3 on both sides. Now again, make sure you distribute this -3 to both terms. And again, here's where students a lot of times will get confused, because now I have an equation of y equals a -1/2 x divided by -3 plus a 10 divided by -3. This is where things get confusing. So first of all, we need to understand, how can I simplify -1/2 divided by -3? Now, again, it's really important to remember, whenever you're dividing by a number, multiplying by the reciprocal is the exact same operation. And the reason why, again, that works is I can rewrite -3 as -3/1, right? And if I multiply it by its reciprocal, a 1 over -3, what does that turn into? That turns into a 1. And dividing by 1, like if I took 5 divided by 1, that's just 5. Right? So if I take -1/2 and divide it by 1, I just have a -1/2. But we have to produce what we call equivalent fractions. If I'm multiplying by -1/3 in denominator, I have to multiply that in the numerator, right? And so what I want you to see is like, oh yeah, -1/2 divided by -3 is really just the same thing as multiplying by a -1/3. Now, a negative times a negative is a positive, right? And 1/2 times 1/3 is going to be a positive 1/6. So therefore, I have a y equals a 1/6x, right? That's going to represent my slope. And then what about this y-intercept, which is a 10 over -3? -3 does not evenly divide into 10, right? So should I leave it as an improper fraction or rewrite it as a mixed number? And this is where I think mixed numbers confuse a lot of students. I don't want mixed numbers. Mixed numbers actually is going to be helpful when we actually graph this. But for right now, for writing the equation, let's just leave this as an improper fraction. Okay, now the reason why writing it as a mixed number will be helpful, because if you wanted to graph this line like this can be confusing for a lot of students. Now again, the first thing we need to do is be able to identify what the y-intercept is. I don't want you putting this as a decimal, right? What I want you to do is think about, like, what is -10/3? Like, where is that on the y-axis, right? How do I find that value? So what I want you to do is just kind of go ahead and convert your improper fraction to a mixed number. And again, that does help you actually plot the value. Now forget about the negative for a second. Let's just do 10/3. Now, how many times is 3 divided into 10? Well, 3 times 3 is 9, right? And then we have a remainder of 1. So 10/3 is the same thing as a mixed number of 3 1/3. Again, I'm not going to use that for my slope-intercept form, but the reason why that's unhelpful, because if I want to find my y-intercept, right, that's a -3 1/3. So I'm going to go down 3, 1, 2, 3, and then I'm just going to go 1/3, right? So it's just a little bit more, right? Just a little bit more over. Now, if I want to go ahead and use the slope, I can go up 1, right? Which would roughly be the same measurement tool, like up like one of those little units. And then I'm going to go over 6 units, right? So by going up, that takes me to like 2 1/3. And then I'm going to go over 6 units. That's going to be using these tick marks. So that's going to be a 1, 2, 3, 4, 5, let's say a 6 right here. So now I'm just going to go ahead and connect to those 2 points. So now let's go ahead and graph the 1/4 x plus 2y equals -2. Now again, I need to go ahead and rewrite that into my slope-intercept form. So to go ahead and do that though, again, I'm just going to rewrite this and just look at my inverse operations. And it looks like everything's going to be pretty straightforward again, right? I'm just going to go ahead and subtract a 1/4 x to both sides. And that will leave me with a 2y equals a -1/4 x minus 2. And then I will divide by 2 on both sides. And I get a y equals, now in this case, again, remember, like dividing by a -3 is the same thing as multiplying by a 1/3, right? So dividing by 2 is the same thing as multiplying by 1/2. So therefore, that's going to give me a -1/8 x, and then 2 divided by -2, right, equals a -1. So now I have y equals -1/2 x minus 1. So this graph is, I'm going to go down to -1, and then I'm going to go down 1, and then over 8. So 1, 2, 3, 4, 5, 6, 7, 8. Now again, it looks like my graph might be a little off right on there. So 1, 2, 3, 4, 5, 6, right? But again, I think you maybe might be able to see like these two graphs are going to be able to intersect, it looks like, at these 2 points. Now, again, I'm not exactly perfect. Let's go ahead and do one more line here going actually over. And I know I'm going to kind of get off on my graph here, but if I go up another 1/3, and 1, 2, 3, 4, 5, 6. If I actually connect those 2 points, what you actually see is I didn't do a good job. Graphing these. So if I actually connect these, you can actually see And again, this is why it's always sometimes gets harder with graphing, that we're going to have our intersection over here. So let's go and find out where this intersection point is. So 1, 2, 3, 4, 5, 6, 7, 8, down -2. The best way to be able to check this would be able to use a algebraic approach. But again, graphing depends on the restrictions. It's just important to be able to understand how to be able to graph something when you have fractions to write in slope-intercept form, as well as how to graph something when you have fractions. You don't always have to have a y-intercept as an integer to be able to graph the equation. Just make sure you kind of keep the spacing exactly the same, so therefore you can go ahead and solve. So there you go, ladies and gentlemen. Hopefully this video was helpful, and hopefully you are now prepared to go ahead and get that A. If you need more examples on solving a system of equations by graphing, or you want to go and take a look at the notes that I provide in my courses, then go ahead and check out the resources and playlists I have for you down below, or go ahead and check out my next video I have for you here. Cheers. What's up, guys? In this video, what I want to do is show you how to find the solution to a system of equations by graphing. Now, remember, when we're looking to the solution of a system of equations, we're basically looking for where these two lines are going to intersect. So one of the main things we need to know how to do is how to graph them. Now, for these three basic examples, we're going to have everything already written into slope-intercept form, also known as y equals a mx plus b. So really the main thing we're going to want to look for is, one, how do we graph our line? How do we identify the y-intercept? How do we identify the slope? Then actually graphing the lines and then finding the intersection points. Once we find the intersection point, the value of x and y is going to be our solutions to our equation. If it doesn't have an intersection point, that means they're like parallel lines, then there's no solution. Or if they're actually the exact same line, then we can say that's infinite many solutions. But a lot of times we're not going to know what it is until we actually start graphing. So let's go ahead and get started into these two equations and follow the process for graphing and finding the intersection point. So in this first example, I have y equals a -3x plus 2. Now, it's really important to understand that my slope, right, is the coefficient of x. So m is going to be a -3 over 1. Now I'm putting it over 1 because remember, slope represents the rise over the run, right? The change in y over the change of x. Now it's really important to recognize that you can keep the negative as far as with the 3, or you can put it with the 1. You could also put it in front. Just whatever you do not put it in the top and in the bottom, because then you'd actually have a positive slope. A negative divided by negative is going to be positive. So I like to put it either in the numerator or in the denominator, because when we're graphing the line, we're going to want to either go in that positive or negative direction, which again, we'll get to in just a second. Now, when we're dealing with the y-intercept, that's going to be your constant in this case. My y-intercept, or my b in this case, is going to equal 2. Now again, the y-intercept is where the graph crosses your y-axis. So remember, when we have a xy axis, there's going to be your y-axis, and this is going to be your x-axis. Let's go ahead and graph this first line, and then we'll get to the next line. So the first thing we always want to do is go ahead and plot your y-intercept. Now again, this is at 2, so that's going to be the value on the y-axis. You can also just go ahead and write this as a coordinate point of 0, 2. So there's our dot. Now from here, what we're going to do is we're going to follow our slope. Now we can follow our slope in the positive direction as well as in the negative direction. And what I mean by that is we could either go in either one of these. So remember, this is the change in y over the change of x. So let's say we did it this first way, right? I did a -3 over 1. So -3 would be going down 3 units. So 1, 2, 3, right? The change in y is negative, so that means we're going to go down. The change in x, though, is going to be a +1. So that's going to be over here to the right. We could also have done this one, right? Up 3 to the left 1, right? Because the change in y is +3, but the change in x is going to be a -1. So if I did change in y, that'd be up 3, 1, 2, 3. And the change in y is going to be a -x. That means we're going to go to the left. Now, you only need to do this once, but I want to connect these points here so you can see how this line is going to be created. It only needs 2 points to go ahead and create your line. Now we need to graph a y equals 2x minus 3. Now this one does not have a negative slope, so that's good. So I can just rewrite that as a 2 over 1. However, it is important to recognize that I can rewrite this as a 2 over 1, or you could also rewrite this as a -2 over -1. Now, for these problems, I think we're going to keep everything simple, but I just want to make sure I bring that up because when we do get into more complicated examples, it is important to recognize that relationship. Now, in this case, my b is going to be negative, right? Because you're minusing a 3. So again, that's going to be my y-intercept, which is a -3, or I could rewrite this as a 0, -3. So again, the first thing you always want to do is go ahead and plot your y-intercept. So that is a 0 along the x-axis, right? And then a -3 along the y. So 1, 2, 3. And now what we're going to do is we're going to follow our slope. And here you kind of have two options, right? You could go to the right or you could go to the left. Well, why would I want to graph it to the left, right? The main goal here is to find where these two graphs intersect, right? Where are they crossing? So I'm going to follow the slope to the right, or another way to say that is I want to follow it in the positive direction. Thankfully, that's the way this problem was originally drafted here, which is +2 over 1. So if I go up 2 over 1, that's going to take me to this point. And again, you only need, guys, 2 points to go ahead and draw your line. But again, I still will draw it at least continuing that same slope in the negative direction. And then hopefully you recognize here that this graph is going to intersect at the coordinate point of 1, comma, -1. And that is going to be the solution to this system of equations. Now, again, another way you could quickly check that is plug in a 1 for the x and plug in a -1 for the y into both these equations, and that is going to make both of these equations true. Now, in the second example, we have some fractions for the slope, but again, that actually makes your life a little bit easier because you already know what the rise is as well as what the run is. The only kind of sometimes tricky thing is, again, when you have a negative, like should you do it in the positive or you should do it in the negative direction? And again, it really kind of depends where you're going to find your solution. Let's go ahead and graph this first example. So I have y equals a 1/3 x minus 6. Again, what you want to do is be able to identify the slope, which is your change in y over your change in x. And then we also want to be able to identify our y-intercept, which is in this case is going to be a -6. So first thing we're going to do is, again, plot my b, which is going to be -6. So I'm going to go down 6 units. So from the origin, go down 6. So 1, 2, 3, 4, 5, 6. Then I'm going to go ahead and follow my slope. Now I'm just going to use the positive version because it's much easier to go up 1/3 than it is to go down and to the left. If we don't need to include the negatives, why don't we just stick with our positive for a second? So I'll go up 1, right? That's our rise over the run. So up 1/3, 1, 2, 3. So now I got 2 points, and let's go ahead and connect those. Now let's go and move on to the next line. And again, identify the slope and the y-intercept. So y is equal to a -2/3 x minus 3. Okay, so this one, my slope is going to be a -2/3. Or you could also write that as a 2 over -3. I think when you do have a negative slope, it is important to kind of give you both of those two options. So therefore you can kind of recognize which one you want to be able to follow, to be able to match up to your other line. And then my y-intercept in this case is going to be a -3. So I'm going to go down to my y-intercept of -3, 1, 2, 3. Now I don't want to go to the left, right? I want to go to the right. I want to use the slope ratio where my x value is going to be positive. Well, in this case, the original slope is that, right? It has a -2. So the change in y is down 2 units. And then the change in x coordinates is going to be to the right 3 units. So 1, 2, 3. And you can see that, again, these two lines are going to intersect at this coordinate point. Now this one, I'm just going to go and check. So this is going to be at 1, 2, 3. And then it's going to be down 1, 2, 3, 4, 5. So at 3, comma, a -5. And again, that is going to be the solutions to the system of these two equations, right? If you plug in a 3 and a -5 into both of these equations for your x as well as for your y coordinates, then that's going to satisfy both equations, meaning both equations are going to be true. All right, in this last example, you can see, again, we have two equations, y equals 2x minus 1 and y equals 2x plus 5. So again, we just want to be able to graph this, and I want you to be able to kind of visually see what's important about this graph, because the slopes here are going to be the same thing, right? You could say m is going to be 2 and b equals -1. In this case, m is equal to 2 and b is equal to 5. So again, let's just do one graph at a time. So if I go down to -1 and then I go ahead and follow the slope, right, which is technically a 2/1, meaning I'm going to go up 2 to the right 1, right? And now let's go ahead and connect those 2 points. And you can see our first graph is going to look like this. Now the next graph here has a y-intercept of 5. So 1, 2, 3, 4, 5. Now again, we're going to do the same thing. We're going to go up 2/1, or you could say down 2 to the left 1. You only need 2 points, but again, I'm going to the left because I kind of ran out of space here. But the main thing I want you to be able to see here is these lines look like they are actually never going to cross. They look like what we call parallel lines, right? And again, we can actually confirm they're parallel lines because the slopes are exactly the same. Since they're parallel, their slopes are the same, they're never going to intersect. Therefore, this is an example of no solution, meaning there is no coordinate points that's going to satisfy both of these equations. It's just never going to happen. And again, that kind of like makes sense. Like, what number could you multiply by 2 and subtract 1, which would be exactly the same as multiplying by 2 and adding 5? It's just not going to happen. So always look out for when you have the same slope but different y-intercept. That is going to create a situation where there is no solution. But hopefully in this video, you got at least a good foundation for graphing a system of equations and finding the solution, which is the intersection point. If you'd like just some more examples of graphing basic systems of equations, or you'd like to go and take a look at the notes and resources I offer my students inside my courses, then go ahead and check out the links and information I have for you down below. Cheers.